Okay, question 2M7. This is the final card problem, but this is set up very much like question 2M4, where we have three different playing cards, and they all have two sides. One card has two white sides. One card has a white side and a black side. And the third card has two black sides. Okay. We put these into a bag, and we pull one out without looking and put it on the table. And we notice that the side that is showing upwards is black. And in question 2M4, we're asked, what is the probability that the other side is black? Or in other words, what is the probability that the card we've drawn is the black card? In this question, the thing that is different is not only do we pull out a card where the face up side is black, we also pull out a second card. And we only know that one of the sides is white. And so we're still being asked to find what is the probability that the side on card 1 here is black. In other words, we're still being asked for the same probability, but this time we're given a little bit more information, which is a second card which has one face showing white. So on some level, you should have the intuition that because we get to see a second card here, that even though this doesn't directly tell us what the other side of card 1 was, there is some information. And the reason that there's some information about seeing this second card and that it has a white side is because after we drew this first card, it's because the second card that we drew is dependent on the first card we drew, right? So these two observations are not independent. They're dependent. So for example, if the first card that I pulled out was the white-black card and I just happened to see the black face, this white face could not be the white-black card. Why? Because I've already pulled the white-black card. So because of that, we can't treat these two pieces of information as independent. We have to think about them as being dependent, and we're going to treat them as a sequence of observations. So rather than saying, okay, well, I saw a black face, and then my second piece of information, so if my first piece of information was I saw a black face, and the second piece of information was that it was white, or that I saw a white face, we're not going to treat these as independent observations. Instead, we're going to treat these as first I saw black, then I saw white, as one piece of information. Okay, then I saw white. So let's start setting up our Bayes equation here, and it's going to be a little bit more involved because of this dependency in the data. Okay, so still try to get this, there we go. So we're still looking for a posterior probability, and it's similar to what we've already been looking for. We're looking for the probability that the first card was black, and so I'm going to call this black 1, subscript 1, to denote the first card, given that first I saw a black face, and then I saw a white face. And so rather than represent this as two independent pieces of information, I'm going to call it B-W. Okay? And so I'm going to come up with my likelihood here. And so my likelihood is going to be what is the likelihood of seeing black then white if my first card was black, times my prior probability of seeing black, and then divided by my marginal probability of all of the ways that I could see black, white. So let's start filling these terms in here. So in this problem, we're being asked to assume that the prior probabilities for each card of card 1. Oh, I should have been denoting that this is all the prior probability that the first card was black, black. Okay. So we're asked to assume that the prior probability of the first card was the same for all of them, and that is 1/3, that we were just as likely to pull the black, black card as we were the white, black card or the white, white card. Okay. So now we need to come up with the likelihood of seeing black on the first card and then white on the second card, given that the first card that I drew was black, black. Okay. So to do that, we can just kind of count the number of white faces. So if the first card that I pull was black, black, then no longer is black, black in the running. Okay, and that takes care of having observed black, because I would see that every time. And so now I need to figure out, of the remaining cards, how many white faces are there out, and how many total faces. And so we see that there is 2 cards remaining with 2 sides, so there's 4 total sides, and 3 of those are white. Okay, so 3/4 of the time. So when I draw black, black first, 3/4 of the time I should be getting a white face on the second card, or on the second face-up card. Okay, and so finally we need to come up with the likelihood, and this is going to be a little bit of a mess here. This is where the difficulty of the problem comes. We need to figure out all of the ways that we could observe black, white. Okay, so if you remember from a couple of videos ago, we found a way of finding the marginal by taking a weighted average, and so we were weighting all of the priors and all of the likelihoods. Okay, and so if you recall, the marginal, we were taking the sum of every possible instance. In this case, there's 3 possible instances, 1, 2, 3 cards, of the prior times the likelihood for each of these. Okay, so that means that for every one of these cards, we have to go through and find the prior and the likelihood of this sequence. So let's do that. Let's scroll down. Okay, now let's get a different color in here. So let's say that the first card that we drew was white, white. Okay. So we know that in fact, I'll put the priors in this column. Okay. The prior is 1/3, and the likelihood, again, the likelihood of observing black then white, in this case it is 0, right? Because if I draw white, white first, I cannot observe black first. Okay, so now let's go with white, black first. Again, my prior is 1/3. And now what about the likelihood? Well, if I draw white, black first, only half of the time is the black face going to show up, right? So when I draw the white, black card, only half of the time am I going to get the black face up. Now, when I get the black face up, I have 2 cards remaining, the white, white, and the black, black. Okay. Whenever I draw the white, white, I'm always going to get a white face up, and whenever I draw the black, black, I never get a white face up. So that means that of the 4 total sides remaining, 2 of them will produce a white, and out of 4 total sides. And so this is equal to 1/4, right? So half the time, so 1/2 times 1/2 is 1/4. Okay, and so now finally, the black black. We've already actually seen this above, but the prior is 1/3. And if you remember, this is the same term as this right here. Okay? And so 3/4 of the time, the second face is white. Okay? So to get the likelihood, I need to take the product of each of these and then sum them up over, well, I'll sum them up over here. Okay? So this, okay? So 1/3 times 0 is just 0. 1/3 times 1/4 is 1/12. Okay. Then 1/3 times 3/4 is 3 out of 12. So I'll make this 0 out of 12, just for good measure. And now if I sum all of these up, I get 4 out of 12, and 4 out of 12 equals 1/3 as our marginal. So let me scroll back up. Okay. And so my marginal here is 1/3. Okay, so let me just kind of compile all of my terms here. So I have 3/4 times 1/3, that's a 3 there, times 1/3, okay? And so when it's written like this, it's easy to see that this term and this term just cancel out, and so my posterior probability is 3/4. Okay. So if you recall back from question 2M4, when we just had one card to look at, in 2M4 we just saw this, and the posterior that we came up with that was 2/3. It was I don't know where to write this to make it make any sense anymore, but in question 2 and 4, the posterior probability of black black was 2/3. Now, with a little bit of additional evidence, we have adjusted the posterior to 3/4, and this should make sense, right? We had some evidence to suggest that the card that we had was 3/4. And because the second card that we saw had a white face, we knew that it couldn't be the black black card, meaning that there's a greater probability that the first one that we drew was in fact black black.